It's interesting. We don't really consider ourselves DevOps nor rugged, although we all have beards. So I don't know what that really counts for. But we're on the product security team at Twitter, and that means we work on code that ships. And we're going to talk to you today about some of the security automation work that we've been doing. And more specifically, we're going to talk about the future and the direction that we're headed as a team to solve some of the challenges that we see happening in sort of the tomorrow of application security. So we're going to show you some cool technology that we've been working on, some of which is open source and available, some of which is still in progress and we're hoping to open source soon. But we really kind of want to show you why we built what we did and sort of why we don't do some things, why we choose to do others. So in order to do that, I want to start off with a little bit of a history, Twitter's 7-year history. So Twitter isn't a particularly old company, but it's a company that's changed a lot. So this is the logo in 2006. This is the new logo. Of course, one of the things you might notice is that if you flip it over on its side, it looks a lot like an angry Batman. First, we released the logo like 1 day later. Someone came up with this. So it's a company that grew very quickly and very publicly and had a lot of infrastructure challenges as it was growing. So some of you are familiar with the fail whale. This is sort of the security fail whale. This is one of a few of the high-profile account compromises at Twitter. This is where the president's Twitter account was hacked by someone who was advertising, and it happened through an exposed administrative interface. And this got the attention of some very notable people, including our friends at the FTC, who issued an order for us to have an effective information security program for the next 20 years. And so we all joined after this order came into effect. But our first challenge was dealing with a large and rapidly changing code base that was under constant attack. So a simple XSS problem could lead to an XSS worm, which was a big concern for us and a big concern for our friends at the FTC. So we also had a lot of white hats who were helping us by reporting vulnerabilities. And there were times where we were just receiving floods of reports of different bugs that were happening. And it really took us a while to kind of get our feet on solid ground. But what happened was we were sort of able to fix a lot of the underlying issues. And then we had this period of reflection to sort of think about, OK, well, what do we want to do now that we've sort of addressed some of the most obvious things? How can we really be more effective in the future? And this happened right around the time of a hack week, which is 1 week every quarter. We're allowed to sort of work on one project. You demo it in front of the whole company. And so we'd stopped sort of dealing with emergencies, and we were thinking about, OK, how are we going to use automation to make our jobs easier and to make us better at what we do? And so we took this opportunity to build out our automation dashboard 1.0. And the first thing we did is think about, what do we think is true with regards to security automation? Like, what are some of the guidelines that we want to follow? And so we use these to sort of shape the way that we built what we did. So here's the first one. And by the way, we have philosophers who are saying all of these things. So the first is to get the right information to the right people. And the insight here is that writing secure code isn't about technology. It's really about people interacting with technology. And our job is really to augment existing social processes. So unless there's like one person who's writing the code and reviewing it and shipping it, it's really about communication. And communicating about vulnerabilities is just as important as finding them. And so what we didn't want to do is have this situation where we ran a tool, got this huge report, and then sent it to someone. We wanted something where we were taking exactly the information that was needed to fix something and sending it to the person who was responsible for fixing it. The second principle was to find bugs as quickly as possible and to fix them as quickly as possible. And this is not a new thing. People have been saying this for a long time. But focusing on it as you're building something really leads you to identify where the bottlenecks are and where the latencies are. For a while, we were dealing with the same types of bugs over and over. And we found that the best predictor of the next bug is the last bug. And so what we've done is we've done root cause analysis on some of the mistakes we've made and used automation to prevent those types of mistakes from happening in the future. There's also a lot of ways to find security problems, and there's diminishing returns from each different vector. So we have tools that live on our servers, outside our servers, and even in our users' browsers, and we use them all to catch different types of issues. Security automation results aren't always entirely accurate. And so we want the fantastic engineers that we work with to trust what we say. And so we want to make sure that they have a voice in the process. If we're wrong, we want them to let us know, and we want to not bother them with information that's a false positive. Also, we've found in our organization, most people want to do the right thing. So all you have to do is just give them the information and the power to fix stuff, and they'll do it. So really making sure that they have all the context they need is important. The whole point of automation is to not do work that you can relegate to a machine. And we found that anything that doesn't require either judgment or creativity is suitable for automation. And so we're really relentless about making sure that we're not doing any work that we don't need to be doing. And then finally, notable philosopher Taylor Swift. We have found that that building our own tools in a lot of cases has allowed us to achieve better results and save time and money because we're able to look for the things that concern us as an organization. It's a very narrow set of security concerns because each organization is different. They have different technologies, they have different processes. And so we found that by building our own stuff, we've been able to do a lot of really cool things that are very much in line with the way that we want to work. So we had these philosophical guidelines in mind when we sat down and decided to build something. And I'm going to let Justin talk about what that is.
Thanks, Alex. It's the first time I've been a part of a talk where people showed up. All right, so as Alex said, we sat down at a hack week, and we wanted to see about automating our security. And so I want to talk about how we kind of took those philosophies that Alex just talked about and applied them in this case. So automating security, it's not really just about using automated tools to do security stuff. So if you have these manual security tasks, which we all do, you have code that's being written, you need to review it before it goes out. You got to do penetration testing against your websites, poke around, see if you can find anything wrong. And then at Twitter, we deal a lot with external reports coming in from people. And ideally, they're reporting those to us and not just posting a blog post on them. But we're relying on them to do some manual work for us. So we can kind of partially automate these. So code review, there's obvious things that we can use static analysis tools to find. Penetration testing, again, use dynamic analysis tools to find the obvious stuff for us. And then external reports, we can augment by using content security policy in browsers so that we get those external reports sooner and more reliably. So this is kind of the workflow event. We have a tool, we run it, we browse the internet for a little while, wait for some results, we get back a stack of reports, then we have to go through them and kind of be like, oh, this is right, this is totally bogus. And then we have to find the person who's responsible for fixing them. And then the code changes, there's new code, there's new projects, and we get to do it all over again. So even though we're using automated tools, our workflow is still manual. So what we want to do is put our robots to work. We don't want to have to go through this manual workflow all the time. when we can have a machine do it for us. So if we let the machine do sort of the dumb work and just notify us when things need attention, we can focus our attention on other things. So for static analysis, we can just run that as code is committed. As the new code is coming in, run the tools, send in the reports. For dynamic tools, we can have those running all the time in the background. And again, the reports go into the same place. And when there's something from any of those reports that we need to know about, let us know. So this is all about automating the dumb work. This is all about pushing buttons, gathering reports, getting all the information in one place. So once we've done this, we can relax a little bit, and we can focus our attention away from the dumb button pushing tasks to things that require creativity, that require deeper investigation. So going back to Hack Week, we had kind of a half solution in place using Jenkins Ci, which is an open source continuous integration server. And it worked okay at first for static analysis stuff and running stuff as code was committed. But we had a much wider range of tools that we were hoping to get into an automated process. And on top of that, the notifications that we got for Jenkins, they just didn't really fit into the workflow that we were hoping to have. So this is what we ended up building. We call it the Security Automation Dashboard, or SADB. And this is a central service to handle all of our automation tools, gathering all the reports, and then notifications. And it's not just a dashboard for us as the security team. It's also a dashboard for developers, for anyone who's interested in looking at what are the current issues with this project or that project. So this is kind of how it works. We have all these different tools that we have reporting into it. And as you can see, we kind of have a variety of sources. We're going to talk about each of these tools. But we have reports coming in from static analysis. We have reports coming in for dynamic analysis. We have CSP reports coming in. We have tweets coming in to our threat deck. And we have code review tracking, which we track in this process that we're going to call Rochambeau. And once all those reports come in, then SADB can notify the right people, whether that's developers, whether it's the security team. So the first tool that I'm going to talk about is called Brakeman. It's an open source static analysis security tool for Ruby on Rails. I am the primary author on it. It detects all the usual problems: SQL injection, cross-site scripting, open redirects, as well as Rails-specific issues like mass assignment, model validation, default routes, CVEs for specific versions, and a bunch of other stuff, of course. I presented on this last year at AppSec. There's been a bunch of changes since then. It's gone from version 0.8 to 1.8.2. And a ton of stuff has gone on. As you can see, it's gotten way faster, for one thing. And we're continuing to work on it, of course. So as a static analysis tool, you can run it basically anytime, right? You could run it after code deploys. That's way down there. That would be kind of silly, though, because the code's already out. You could run it as part of your QA process. You can run it for code review. You can integrate it with your continuous integration server. There's a plugin for Jenkins. You can run it as a post or pre-commit hook. You could run it as part of your tests if you wanted to. Or you could run it as the developers are saving their code. So using file system monitoring, just have Brakeman run immediately when a developer hits save. And that's pretty much as fast as you could possibly find a problem. So this is fitting in with our philosophy is finding the bugs as quickly as possible. So the integration with SADB looks like this. It's not too surprising. Developer pushes up code. And then we have Mesos is an open source tool for running jobs, basically. I don't know much about it, but it's an Apache project. It pulls in the code, runs Brakeman against it. For each commit, it sends down a report to SADB. SADB then looks at the report, looks at the code, and says, okay, if there's a new warning, I'm going to email the developer who committed this code. If there's a branch and it used to have warnings and now they fixed it, I'm going to send them a congratulatory email and say, good job, you fixed all the problems on this branch. So this is about getting the right information to the right people. You know, on one end, we could have like a huge report that we like just send to the entire development team for that project and like, all right, you guys figure this out, fix all this stuff. On the other side, we could just like have the report for ourselves, right, on the security team and be like, oh, all right, these are the problems. But this approach is, hey, these are the developers, they wrote the code, let's just send them an email and they'll be notified as soon as possible. So the other thing with having a central place to gather all these reports, of course, we can get some nice historical trends. We can look back in time and see, oh, what happened here, what happened there. Make sure things are on a downward slope. This is number of warnings, so we want that going down. These sort of big drops at the beginning, that's around when Twitter started using Brakeman pretty heavily and making a concerted effort to fix the warnings. The spikes that you see, these tend to be releases of Brakeman. So improvements to Brakeman, not the developers pushing out a whole bunch of problems. So this little one here was Brakeman 1.6.1. And over here, Brakeman 1.7. And the reports look something like this. So we have, you know, a breakdown of what kind of issues we're seeing, the confidence levels. You can search and sort and filter, do all that kind of stuff with the different warnings, and view different branches if you'd like to. And this, you know, it's not just for us, the security team. This is for developers looking at this and going, what's going on here? I want to fix stuff. So if we look at a single warning, looks something like this. And this is, again, what a developer might follow a link from one of those notifications. They would see something like this. So obviously, that's the message up there. Because we're scanning each commit as it gets pushed, we can point out this is how long ago this was committed. We can link directly to the code location and line number in the code repository. And then we have a view of the code that Brakeman is warning on, just as Brakeman saw it and as it interpreted it. Down at the bottom, if a developer comes to this page or a security person comes to this page and goes, I don't know what it's talking about, we have inline documentation down at the bottom. And this is specific to Rails. It's not just like a CWE description of the problem with information on how to fix the problem as well. So this is all about helping people help themselves. We have the information right there. You know, they don't have to be angry and confused when they go to this page. They can read and go, okay, I know what to do. I know what the problem is. Over here, we have our false positive reporting button. So again, someone goes to this page and is like, man, this is just totally bogus. I don't believe this at all. They hit that, it emails us, and you know, it's about having that dialogue and being like, you know, we're not just pushing down this stuff at you. You're welcome to be like, hey, man, I don't believe this, or I don't understand this. I don't think it's real. So we have a video here which shows this in action. Click on it. Did it work? It worked. Then it stopped. Click again. All right. So here, developers, I know it's hard to see, but got a new branch, gonna edit some code, gonna, you know, maybe introduce a problem. This is Rails, of course. So they're gonna do a redirect to a param, push up the code, see in the corner, oh, I got an email from SADB. That's probably a bad thing. Look at this, you see the vulnerability, see the file. All right, I'm gonna like check this out. Go see SADB, all right, here's the file. Here's information on how to fix it. Reading. Oh, all right, here's like some code to mitigate this. All right, I'm gonna go back. copy paste that code right in there. Typing. All right. Save that. Push up my changes. Over in the corner, you can see, all right, oh yay, I got another email from SADB. Let's check that out. And hey, you fixed everything. Good job.
I think these guys.
I think there's my understanding is there's a large number of people at Twitter using BI. No? I do. Okay. All right. So what about the future of SADB and Brakeman in particular? So you notice nowhere in that flow were we saying like, hey, don't deploy this. We would like to do that. So eventually we'd like SADB to sort of be the source of truth where the release tools can say, hey, SADB, can I release this? And SADB can go, yes, good, or no, we don't want you to release this. We think there's some problems. Of course, this flow that you saw is not particular to Brakeman. Any static analysis tool would make sense in this, and we're working on getting some stuff going for JavaScript static analysis and also Scala, and especially for our internal web frameworks that we use. And I think that's it. Oh, if you want to know more about Brakeman, tomorrow morning it will be at the open source showcase right over there somewhere. All right, I'm going to hand it over to Neil.
Thank you, my bearded friend, my rugged bearded friend. Now I'm going to talk about Phantom Gang. Phantom Gang is complementary to static analysis. It's a dynamic analysis tool that pretty much came directly from a class of problems that we were just seeing pop up over and over again that may or may not be easy to detect with static analysis. So what am I talking about here? Specifically, I'm talking about mixed content. Static analysis might be able to find this, but it's very easy to detect mixed content with a dynamic crawler. You could even detect this with just a simple curl command. Sensitive forms posting over HTTP. If you have a password, you never want that to go over clear text, obviously. But if you're on an SSL page and you're posting to a non-SSL page, you probably don't want to do that either. We had a bunch of microsites pop up or new projects pop up, and they just kind of grabbed whatever jQuery they had on their computer at the time. Obviously, this is bad. Updated versions of jQuery are much more robust against things like DOM XSS. So we want to make sure we're not using any old versions. And we're also seeing a lot of forms with authenticity tokens missing, which leads to cross-site request forgery in a lot of cases. So, like I said, we came up with a tool called Phantom Gang. Phantom Gang, as you might have been able to tell already, is sort of complementary to traditional dynamic analysis. We're not looking for cross-site scripting. We're not looking for SQL injection. The other tools do that. We're looking for very specific problems that we're seeing recurring over and over. And obviously, we don't ever want to repeat those mistakes again. So what is Phantom Gang? Phantom Gang is basically a series of Node.js processes. Node is basically just a JavaScript runtime environment provided on the V8 platform. And it basically spins up a bunch of instances of Phantom.js. And Phantom.js is a headless WebKit browser that can be controlled by JavaScript. So it works very nicely. And now it's a WebKit emulator so that we pretty much can see exactly what the user is going to see in their environment. If it finds any of those issues, as well as a few other that I didn't mention because they're kind of boring, it posts the results to SADB. We don't get the cool automated workflow like, hey, you get an email as soon as we find this result. I'll get into that a little more later. But from there, we basically just file an issue through our Jira, our tracking system, which happens to be Jira in this case. So I mentioned that it's kind of difficult to see who should get the report. I mean, you could have X number of applications running on a single host. URL schemes might be drastically different from one place to another. So it's really hard to trace that back to the developer who wrote the code. So we've basically just used a simple active admin interface for those familiar with it that gives us the very basic searching, sorting, filtering, things like that. It allows us to group things together as we see fit into a single JIRA ticket, and then we assign it to the person that we think is supposed to handle it. So we've got some thoughts for Fandom Gang of the future. A lot of this was actually inspired by conversations with the Etsy folk, because they are also awesome at automation. One of the things we'd like to see it do is incorporate their, did this XSS fire on a page technique, which basically will override some of the native methods, inject an attack payload, and see if any of those methods fired. Very easy to integrate this into Fandom Gang. Justin had talked about JavaScript static analysis earlier. This is a perfect springboard for such a thing. If you have a directory, you might have however many JavaScript files. You have no idea how they're related. 5 might be on one page, 3 on another page, snippets everywhere. You never know. So by visiting the page, you have exactly what you need to know. Suck down all the JavaScript, spit it to our analysis, and we should get good results. And we also plan to open source this at some point. Not sure when. It's a very rough work in progress that seems to be working well but has some usability issues. So now I want to talk about CSP. I personally am a big fan of CSP, and so is Twitter as a whole. CSP is just a policy that defines what can run on a given page, and any deviation from that will trigger an alert. This alert comes from the user's browser. So this is, we've got static analysis, we've got dynamic analysis, and we've got a browser sending us all this report. We have all this information that's completely complementary to each other. CSP is great for protecting certain things, but it's also great for analyzing what's going on your websites. We can get a lot of these reports and deduce a lot of information from it. So basically, any CSP violation that we have, we send to a centralized logging point, which is just a scribe endpoint, which is just massively scalable logging. From there, it gets written to a Hadoop cluster, which we get all of our awesome big data capabilities there with things like pig scripts and maybe a scalding script, which is just a Scala abstraction of pig, from what I understand. So once we can run these huge data sets or analysis over huge data sets, it's really easy to pick out trends. It's also really easy to pick out trends of false positives, because something like CSP, you are going to have to tune a lot. I was talking to a Mozilla guy earlier today, and he was kind of shocked because our biggest problem was Chrome extensions. It's kind of an easy fix, but infected browsers. We're getting reports, and we're going to these pages, and we're like, I have no idea how this could have triggered a CSP violation. And we basically came down to the conclusion that the user's browser must have been infected. So I had talked about using big data to detect things. If you see a spike in activity, probably want to investigate it. If you see a violated script source directive like this, which is a very strict directive, which basically says JavaScript can only be served from my host, and there could be no JavaScript on the page itself, completely external. This is also a trend that developers are moving towards, so it's kind of like a win-win there. But if you see this type of violation, you can almost be certain that there is a valid cross-site scripting attack on your web page. It's great that we get these reports, but it's also scary because not every browser supports CSP. So while we're saving some users, we know that other users are at risk. Another thing that CSP is also great for detecting is mixed content. We had talked about the dynamic tool that detects it, but we can have our users tell us when there's mixed content as well. And like I said, this is just an example of hitting things from all angles. Dynamic, static, browser, everything. So we had an early win when we started using CSP on the mobile Twitter website. This is a tweet from one of our white hats. He's great, keeps giving us information. And then, so I ran this through Google Translator, which gave me a horrible translation. So I'll translate what Google says. Basically, he said that he had a successful cross-site scripting attack against Twitter, but as soon as we implemented CSP, gone. It was the first time he had ever seen such a thing in action. Oops. So this is kind of tangential to the main topic of SADB, but let's stick with the topic of headers. We applied CSP to a lot of our websites, And then we realized it's kind of the same strategy for everything. And then we're thinking, well, there's other headers that give us great benefits that the browsers provide this protection for, but they're kind of applied haphazardly, one-offs, maybe not even correct in the first place, maybe not even on all the requests, whatever. So we want to make sure that we enforce things like strict transport security when we can. Make sure that the browser never hits that HTTP page, never gets that redirect, protects from things like fire sheep attacks and SSL strip, et cetera. But again, this is also something that other people will be on board with. Developers, ops, product guys, everyone. That takes away one request from your web server, so it's a really easy sell. And at the same point, HSTS has this concept of including a subdomain. So anything.twitter.com has to support SSL, which is not true at the moment. So it's a way to poke and prod our ops and all the people in charge of that decision to say, like, hey, this is a big win. Can you help us? Another one, extreme options, protects against some classes of clickjacking attacks. Not too much interesting information here, pretty easy to apply. And then IE has a couple headers that are somewhat useful. So putting this all together, we thought, why can't we just apply headers to all requests over all our applications in a consistent manner that's easy to audit and easy for developers to use? So we created a simple library that'll inject these things with maybe 10 lines of configuration, and now your whole application is getting all of these headers all the time, unless you specifically opt out, which is greppable. And this is really just an example of automating dumb work. It's dumb work because it's easy for us to apply and we understand these things. Maybe not so much for developers, but now we give them a library that makes, takes that all out of their hands. And I think it's back to you.
Cool. So just a couple more things. We had this sort of SADB infrastructure. We wanted to add a few more things. So one of the things we added is something called threat deck. So one of our teammates had this tweet deck set up with columns. Tweet deck just allows you to set up like different timelines, basically. And he had a bunch of different columns looking for various things that indicate someone was trying to attack Twitter, or someone had a successful vulnerability for Twitter, or something like that. So just sort of like monitoring Twitter, looking for different things. And so we built that into SADB. It's basically just a bunch of columns looking at different search terms. It's got like a sweeping radar GIF. It's pretty awesome. And then the last thing is something called Rochambeau. This is kind of funny. So in the past, we had people who were changing code and submitting it, and we just weren't able to see all the code that was being submitted. So what we did is we were able to basically add our names to critical sections of the code so that when people made changes, we were automatically tagged in the sort of review for that change. But what we had to do is we had to go and run this script file and then copy and paste the results into this email. And what we would do is play Rochambeau weekly to determine who had to do this sort of manual work. And the loser would have to go and run this script and do everything else. And we're like, hey, let's go and just build the sort of automation to get these results into SADB. And so now they just automatically show up in SADB, all the code that we haven't reviewed yet that we need to review, which is great. And of course, we still play Rochambeau, and the loser has to go review all that code, right? So what we thought we'd do now is we have some Twitter T-shirts, and we thought if we could get some volunteers from the audience, 4 volunteers. Anyone volunteer? There's 1, 2, 3, and 4. All right, come up here. Just really quickly. All right, so we're going to have a quick Rochambeau contest, and the winner gets a Twitter T-shirt. All right, so do you know how to play Rochambeau? Yes. OK, so we'll start with you two guys. So it's 1, 2, and then throw on 3. So 1, 2, and then throw on 3, OK? And we'll do 2 out of 3. All right, ready? Go. 1, 2, 3. OK. All right, 1, 1. All right, you got that one. You got that one? Good. Now you two go, and then we'll have the winner of this one go against you. All right, it's a tournament. This is how we determine, All right, so you guys go. Ready? All right. Okay, that's a tie. Be more clear with the, yes, thank you. Okay, another tie. Go again. Neck and neck here, all right. There it is. All right, that's one for you. All right, keep on going. One more. Oh, there it is. All right, so now the championship here. You guys, whenever you're ready.
Sure.
All right, ready?
Sure.
All right, a tie. All right, that's one. Oh, that's two. All right. Okay, congratulations. You're the grand champion. We'll get you a T-shirt if you would like one. All right, great. So anyways.
All right. So that was a manual process right there. So to just kind of sum this up, we started off kind of talking about these manual tasks. You know, even if you're using an automated tool, if your workflow is manual, it's not really automated. So we had manual tasks, low visibility. I mean, when you run a tool, then like you get a report, and then what, you like save it to your desktop or something, you know. And then we had, you know, we were kind of relying on external reports to report stuff like, oh, hey, SSL is kind of weird on this page or that page. So that was like really late problem discovery. So we've gone from that, where we're trying to like keep track of everything, to a more automated approach. So we have those manual tasks of like running a scan and getting reports and figuring out who to send things to. We've switched to automated tasks. From low visibility, we've gone to, okay, we can see trends, we can see the reports, we can really drill down into stuff. We could even do, you know, we haven't done it yet, but we could do stuff like who's fixed the most bugs, what's the time from a warning being introduced and a warning getting fixed.
And who needs to be shamed?
Also, who introduced the most problems. And then, you know, we've gone from this sort of, you know, relying on people, white hats, to let us know about stuff, to using, well, and also, you know, kind of, you know, scanning stuff later on, to, okay, let's get notifications when something happens. Let's get notifications from static analysis, from dynamic analysis, from CSP in the browser. So that's just sort of a summary of kind of where we've gone. I think like everything in this presentation was either open source or something we built. So just kind of a summary there. All right, thank you guys.